guys, EMEKA right here. Please do not forget to share my videos with your friends and also subscribe to our YouTube channels for more videos. Now this is second to my last teaching on velocity time graph. Okay, so we are now going to proceed with what? This question. Now let's go. A graph is given. And at this point we have 6. At this point we have 11. At this point we have 21. P R P Q R X T. Now this is what we have. Let's take the question. The diagram above represents the velocity time graph of a body in motion. The total distance traveled by the body is 195 meters. Calculate the acceleration of the body in section OP of the graph. Acceleration of the body in section OP of the graph. Now, to obtain our acceleration from a velocity time graph, we consider what? The slope. We solve for the slope of the acceleration region to obtain what? The acceleration. Now, how do we determine the acceleration? This acceleration is given as what? As slope. To be able to what? Change in y all over what? Change in x. Now, from the graph, that will be what? That will be change in y is what? Pt. All over change in x, which is from this point to this point, which is what? To. Now, we don't know what pt is. Our pt is what? Missing. Pt is from this point to this point, which is same as from this point to this point. That is missing. But in addition, the total distance traveled by the object is given as what? As 195 meters. Now, we have to solve from what we know to what we do not know. From our graph, from the velocity time graph, solving for the area, solving for the distance from the graph is given as what? Is same as what? As the area under the graph. Now, make use of the formula in solving for the area under the graph, which is the area of a trapezium. We will be able to obtain what? Pt. Now, how do we do that? This is a trapezium. This is a trapezium, and the area of a trapezium, we all know that, right? Which is what? Area, which is what? Half in brackets, the summation of the two opposite sides, which is now what? PQ. Plus what? Plus OR. Then multiplied by what? By the distance, which is from this point to this point, QS, which is equal to what? PT. You understand now? So, make use of PT. That's what we are going to be having. Now, the distance, remember the area, we are now going to now substitute it for what? For the total distance, which has been given already to be what? To be 195, which will now be equal to half in brackets. PQ is from this point to this point, which is what? 11 minus 6, and that will give us what? 5, plus what? OR, which is from this point to this point, and that will give us what? 21. Then multiply by what? By PT. Now from this point, we are going to be having what? 195 to be equal to half in bracket. 5 plus 21 will give us what? 26. Then multiply by what? By PT. Now 2 into this will give us 1. Into this will give us what? 13. So we are going to be having what? 195 to be equal to 13 PT. So from this point now, PT will now be 195 all over 13, and that will give us what? That will give us 15. So we have obtained what? PT to be equal to 15. Now, going back to our slope, that will be giving us what? That will be giving us 15 all over TO. TO is from this point to this point, which is what? 6. And 15 all over 6 will give us what? Will give us 2.5. 2.5 meter per second square. That is the acceleration from the graph. Now, taking another question. Taking another question now. Taking another question. We have these graphs. We have these graphs of speed against what? Speed against time. we have these graphs. This is A. B, we have this graph. Then for C, we have this. Then D, we have this. Now the question. A vehicle moving with a uniform speed is gradually brought to rest. A vehicle moving with a uniform speed is gradually brought to rest. Which of the following sketches describes the motion of the vehicle? Which of the following sketches describes the motion of the vehicle? A vehicle moving with a uniform speed is gradually brought to rest. Now, for uniform speed, it looks this way. For a graph of uniform speed, it just looks this way. Then being brought to rest means that the brakes are now applied and retardation now sets in. Now we have it to be this way. So this is the correct graph for the motion of the vehicle. Uniform speed, then brought to rest. Now, thank you, and I will meet you some other time.